so you should have something that looks like this here, more or less. Right, your absences, and I would say you only need to apply 0, 5, 10, and 15. You don't need to have all the numbers, right? But you should label it number of absences or absences, and then up here you should go from, they should have started at 0. That's an error. They really should start at 0, 10, 20, 30, up to 100 for their grade, and then you have something that looks like this, which is a negative relationship. Good. Hopefully that all made sense. Yasura, go ahead and read.
Research wishes to see if there is a relationship between the ages of the wealthiest people in the world and their net worth. The data shows a random sample of 10 persons selected from the Forbes list of the 400 richest people for a recent year.
Perfect. Thank you. Oh, that's okay. You're good there. That's perfect. Thank you. So again, you need to make sure you cover all of your x's. So here's my lowest x and my highest x. So the bottom has to go at least from 38 to 83. This is in the notes. Yeah, this is the front page of the notes, chapter 10 notes. So that's along the bottom, and then the side. Oh, this particular problem might not be. I'm just showing you guys. And then the y's need to go from 0 up to 69. Okay, so this is what it would look like here, right? Age, and it's like this, and then there's the wealth in billions, and you can kind of see how it's all sort of scattered about. There's not a line or any sort of real, straight sort of curve or line that you can draw from this. It's just a bunch of kind of jumbled up dots. So this is no relationship at all. So again, this one's no relationship. Go back to my thing here. This is a positive relationship where it's kind of like a line going up. And this is a negative relationship where it's kind of like a line going down. Okay. And then again, this one where it's kind of just a bunch of random scattered dots, no relationship. All right, so now we're going to talk about rho. Don't freak out. It looks weird, but it's not really weird at all. So rho, spelled R-H-O, is this sort of weird, sort of just a loopy little, it's like a P, but it's not, right? A P would have more like a little, oops, can't freak out on me. If it had like this, a notch there, then that would kind of make it a P. But it's like, you just go up and around, right? You just kind of do this little up and around sort of thing, up and around. Maybe try to do it a little more curved, but that's the kind of the idea, maybe a little more loopy. So that's all that this is just this kind of weird sort of P-like thing, but it's not a P. It's just kind of up and around, and it's called rho, R-H-O. That's the Greek letter. It's kind of the Greek equivalent of an R, so we're going to use an R for the American equivalent. All right, so Robert, go ahead and read.
Population correlation coefficient denoted by P.
Rho
is computed by using all possible pairs of data values, x and y taken from a population. The linear correlation coefficient denoted by
R
is computed from the sample data and measures the strength and direction of a linear relationship between two quantitative variables. The one explained in this statement is called the Pearson product moment correlation coefficient.
PPMC. Great. So again, population is this rho, because population is always Greek letters, right? So it's this weird sort of loopy thing. It looks like a P, but it's not a P. It's just this weird sort of like sloped, looped up, and then curl back around. The equivalent of that for a sample, remember sample uses regular ordinary letters, is R. So we're going to compare R to rho. So this would be similar to like, R would be like your X bar, whereas rho would be like your mu or something like that, right? This is the population one. This is the sample one. And then we're going to be using this PPMC table. So hopefully you guys all downloaded this PPMC table. We're going to be using it over and over again. This whole chapter, you're going to need it for the exam. You can download it. It's on Canvas under handouts. So find it there. Okay, let me move this guy down. Megan, go ahead and read.
The range of the correlation coefficient is from -1 to +1. If there is a strong positive linear relationship between the variables, the value of R will be close to +1. If there is a strong negative linear relationship between the variables, the value of R will be close to -1.
Great. Perfect. So the thing I kind of like, so let me explain to you what I'm talking about here. I'm going to actually stop sharing for a minute. So if there is a strong linear relationship, then R is going to be +1. This correlation goes from -1 to +1. That's its range. The ends are where there's a strong relationship. So at +1, it's a perfect line with a positive slope. When the correlation coefficient is -1, it's a perfect line with a negative slope. And then in the middle, a correlation coefficient of 0 is just like, it's kind of nice. It's just like a bunch of random dots. It's almost like a circle, right, with a bunch of dots in the middle. Whereas this is more like a line. And you know, 1 sort of looks like a line. A -1 sort of looks like a line also. And then 0 sort of looks like a big circle, right? So you can kind of think about that. They sort of follow their shape of whether it's like a line, not like a line at all, more like a circle. If that makes any sense. So that kind of helps a little bit. So let me talk to you about what I mean in terms of a line. So imagine that I go to the store, right, and I'm going to buy muffins. If I buy 1 muffin, then I'm going to spend $3. If I buy 2 muffins, then I'm going to spend $6. If I buy 3 muffins, I'm going to spend $9. So this makes a perfect line, right? The more muffins I buy, the more money I spend. It makes a perfect line with a positive slope. So that would have a correlation coefficient of 1. It makes a perfect line. On the other hand, say if I look at the money in my pocket left over, right? If I buy a muffin, I lose $3. If I buy 2 muffins, then I lose $6. If I buy 3 muffins, I lose $9. So this is making a perfect line going down with a negative slope. And it's a perfect line. The more muffins I buy, I can predict exactly how much money I'm going to lose. Right? If I buy 5 muffins, I'm going to lose $15. It's a perfect line. So this would be a negative slope because as I buy more, it goes down. Right? The money in my pocket goes down. So this would have a correlation coefficient of -1. Okay. So make sure we're all clear on that. So what I'd like you guys to do is take a look at your next spot. Let's see. So you should, first of all, make sure you fill this in from your bottom of your handout, at the bottom of page of your chapter 10 notes at the very bottom. Right, strong positive linear relationship, strong negative linear relationship, R equals, and so forth. So fill that out. I'll give you guys 60 seconds to do that. Oops. Well, I find the slide. There we go. All right, so here it is. This is the slide we want. So this, then turn the page and do this is your next thing to figure out. So take a look on your own take about 30 seconds or maybe 45 seconds on your own and try to figure out which one each of these numbers is. Right, so take a look at that one. Use the one on your list. And I'm going to go ahead and put you guys in breakout rooms. So hop in your breakout rooms and consult and just check with your neighbors and make sure they have the same thing you guys have.